If any people would like to ask questions, we do have a mic because we are recording it. So put your hands up and I'll get the speaker to come up and answer. Phil. So Dr. Philip Ward.
Thank you. My question's for Dr. Matthew Pace, if I'm saying that right.
Yes. Oh, it's actually Pace, but he anglicizes it.
I apologise, my Australianisms.
No, everyone calls him Pace.
You mentioned that the early prediction value of vascular risk factors might be a sign of cumulative burden. Did you look at that directly, and did you look at perhaps the integral of vascular risk over time and whether that was a stronger predictor than just 1 point in your 40s?
It's a pretty good question. No, we didn't investigate that. It's something we certainly could do. The other paper that I briefly mentioned by Ima did look at that factor, but just with hypertension, showing that if you consistently have hypertension over a prolonged period of time, that's a stronger predictor than just having it earlier in life or later in life. But no, that's something we didn't investigate, but it would be quite interesting. Yeah, thank you.
Professor Mashinsky.
Yeah, my question is to Dr. Bivard about TIAs. You mentioned that you had several potential mechanisms for the phenomenon. If inflammation were one of your favorites, then there's some support for it. Alexander Thiel in Montreal showed that after a cerebral infarct, that white matter inflammation was a better predictor of cognitive state at 6 months than the initial cognitive status. So my question to you is, have you considered using those inflammatory markers that are now available with there used to be compounds that only had a half-life of 20 minutes. Now they're available that have 2 hours. Have you considered testing some of the mechanisms that you propose?
Is that with PET specifically?
Pardon?
Is that with PET specifically?
Yeah.
Yep. There's no PET scanner in Newcastle, so it hasn't really been in scope for quite a while, but having moved south, there is one. So yeah, absolutely. We're definitely interested in that, but we're also doing a biomarker study, so collecting bloods to see if maybe there's something a bit more accessible that we can assess in that as well.
Yeah. With a 2 hour, there could be something that could be shipped to you. If it can be shipped within an hour, you can do it at your place.
Oh, well, I'm in Melbourne now, so we can do it here anyway. Yeah.
And the other thing, of course, if that hypothesis is correct, that offers the possibility it can modulate the inflammation, and therefore the consequences.
Oh, absolutely. And that's why I'm quite interested in animal model as well. I think that'll help accelerate some of our understanding around that for sure.
Thank you.
Thank you.
Yeah, these second generation TSPO ligands for PET imaging are really exciting. They are available in Melbourne. At the moment they're just in association with pharma studies, but they can be done. So I think that they offer great promise. Rishma.
Thanks to all the speakers, it's really interesting data. I was just wondering, and this is to everybody who's done imaging, have you looked at more direct measures of the vascular health in people, so like the vessel sizes, looking at MRAs, ASL, to look at sort of blood flow? Because what is underlying some of these changes that you're seeing, the correlations between vascular risk function and structure?
I can talk about Canvas at least. So we're not doing ASL in Canvas. We have done it in Pisces and a smaller sub-study. But a couple of the researchers did speak about it. Certainly, Andrew, I think you've done ASL imaging. Again, I think it's just sequence time. We've only got an hour that we pay for. And getting an MRA in addition to that. One of the advantages of clinical imaging that I'll get Andrew to speak about is that patients, when they arrive, do get now routinely a CTA and CT perfusion as part of their stroke, the acute stroke workup. But getting an MRA and MR perfusion is much harder clinically. So we've got beautiful CT data in that acute phase.
Just on ASL, I wouldn't recommend it, actually. The sequences are very variable. The results you get out of it are relative CDF. It's never an absolute value, so whatever you see could be relative to itself and nothing else.
And then it's very error prone. You blink and you need to do some pretty severe motion correction. And then the post-processing of it is also frequently changing as well. So it's a very it's a global assessment of relatively what's going on. We've done it in TIA for diagnosis of a TIA and validated it for that, but a TIA actually results in fairly substantial hypoperfusion as well. And if you get someone with chronic hypoperfusion, say, or just some kind of chronic hypoperfusion throughout the deep white matter, you don't know what you're looking at. It's pretty tricky.
Yes, of course, Vladimir. Mike?
I was quite intrigued by the work of Professor Sullivan and the care he took not to jump to conclusions. If I understood you correctly, is the Florey is selectively vulnerable to vascular risk factors? If so, have you been able to unbundle which one it is? If it were hypertension, for example, we would emphasize controlling that. And you have large enough numbers, you probably can answer that question.
Yeah, I think we only partially have the answer for it, though. And I think that there's a little bit of complexity that I glossed over in the results, in that there are multiple measures of microstructure performance, and they have differential associations with risk factors. So for the waist-tip ratio, you see associations with some components of the diffusion metrics, and for hypertension you see associations with different diffusion metrics. So there is this complexity about really understanding what those associations mean at the ultrastructural level, and that's one of the challenges. There's no single metric that correlates nicely with selected risk factors.
Great. We have a question from the back. Professor Turlough, Leonard?
Thanks. My question is for Michael as well. Michael, thanks a lot for presenting very interesting data. The question that I've got is, you were referring to these models as predictive models, but at the same time reported p-value, which is probably a model of association. So I just wanted to double check, was that an analysis of association, or was actually a predictive model that was validated from testing training sort of data?
Yes, I'm sorry if my terminology was a little loose, but the data from Rotterdam is data that's longitudinal and so the Rotterdam collaborators actually are very careful about this terminology, and I've probably misrepresented it. So the data from Rotterdam is true prediction based on longitudinal data from different time points. All of the rest of the data I presented is association. And that's why I'm being very careful about the caveats of this, because these are structural equation modeling approaches to cross-sectional data that are trying to model directional relationships. But there are clear caveats in terms of the possible effects of confounding, which is, I think, really important in terms of being cautious about causal inference from that data.
Thank you. Scott, Dr. Aiden.
I just want to thank all the speakers for a really great session. I had a question for both Dr. Lim and Dr. Passay, which relates to the effect of E4 on both, two questions related to E4. Does this impact on the cardiovascular risk factors, and does this mediate the link between those cardiovascular risk factors and cognitive or other outcome measures related to Alzheimer's disease?
Thank you. Yes, we haven't genotyped the entire cohort yet for ApoE4, but we will be investigating that. Some data from APOE does suggest that ApoE4 does somehow mediate that relationship between vascular risk and cognitive decline, so it'll be good to see in this cohort whether that occurs as well.
Thanks, Scott. In our cohorts, we see it all. We see it all the time, actually, in Framingham, where if we look at interaction by ApoE4, we see differential effects in carriers versus non-carriers. So it's actually a pretty common finding whereby you find differential effects by ApoE4.
So to clarify, are those people E4 positive? the cardiovascular risk factors matter more for their future cognitive impairment than
It's actually,
for cardio?
a lot of the time, yes, but actually for some things it goes the other way. We've seen some vascular risk factors seem to be more important in non-carriers. And the reasons for that are not 100% clear, but certainly looking at interactions with ApoE, it comes up significantly far more than you'd expect based on chance. But the direction of effect based on carrier or non-carrier is not always consistent. I don't know if anyone else has anything to add.
Are there any other comments from the audience? Any ApoE4? Sheila, did you want to comment?
Yeah, just want to say thank you again to all the speakers. We've heard about potential pathways or mechanisms that might be causing dementia. We've talked about the vascular risk factors, tau, beta amyloid, but I'm just wanting to ask whether there are any other emerging factors, biomarkers that are current or genetic factors that are being measured that are showing sort of promising associations with dementia.
Should we get Yen to answer that? Or Matt, did you want to answer that? I think Yen's had an interest and published some very nice papers on some things.
I was just going to add that, sadly, finding things that predict dementia is quite hard, and everything seems to have very small effects. So I think if something jumped out as having a huge effect, we would have found it by now. We often find that things add to what we have, but for example, if we're developing risk prediction models and things like that, adding to, say, age, sex, and ApoE, it's really challenging. So we're searching all the time for biomarkers and other risk factors, but it's been a difficult search.
Yeah, we've worked on a couple of genetic risk factors for Alzheimer's disease. ApoE unfortunately swamps the variants a lot. I know groups that have worked on polygenic risk scores and different things like that. I personally have worked a lot on BDNF, so brain-derived neurotrophic factor. I'm interested in it because it is a good psychology gene, and that means that it has 3 possible variants: MET, VAL, or MET-VAL, or MET. And we've seen that it has an impact on hippocampal volume, on cognitive decline, on CSF tau and p-tau accumulation. The relationship between BDNF and physical activity is also really interesting. So there are all these different relationships that we can sort of start to tease out. I think that's a completely other talk that I can give, but I can talk to you a little bit more offline if you're interested. But yeah, there are lots of other cognitive genes like COMT and KIBRA and CLOTHO that seem to impact on the cognitive reserve sort of pathway, how they operate mechanistically. I might have to defer to Scott Ayton and his team at the Florey to discuss some of that. But yeah, they're definitely like little genes that sort of pick up. And using GWAS to identify risk alleles don't necessarily translate into clinical outcomes. So all the GWAS risk alleles beyond ApoE4, like clusterin and PICOM and sorrel, they don't seem to have an impact on clinical disease progression. So that there's also that consideration to take into account when interpreting genetic results.
And I should comment that Michael Breakspear's group in Queensland and Newcastle are actually looking at this. They've got a big project looking at polygenic risk scores and dementia risk. So we're running into our morning tea time. We can go 10 minutes over, but if there's one, not another burning question, obviously you can grab people. Yes, Phil.
I'll be very short. I just wanted to comment on the E2 and E4 differential mediation. There was a paper just in the last year looking at protein expression along the vascular atlas or vascular axis in the rodent brain, I believe, and they looked at expression in the endothelial cells, in the astrocyte end feet, along the arteries, capillary bed, and venous axis throughout the whole brain, and they found very significant differential expression of E3, E2, and E4 variants in those different cells. and that might point to some of the relationships between E4 and not E4 carriers affecting different systems and resulting in different risk factors.
Great, thank you, and thank you for your questions and for your attention. So we'll break now, and I think that we'll go 10 minutes over, so start at 12:10. I know it's quite a late break, but we're Melburnians, so everything's late. And we will reconvene at 12:10, and then you will have a late lunch, which you can deal with.